Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. It was requested of me to do a teardown video for a Nucular 24 FET, and so here you go. This is the third video in the series, and now we're doing kind of a more close-up look on things. I have a halo light around my macro lens, but the thing just died. It flickers and flashes and won't stay on. So anyway, we have to do this with overhead lights, and as a result you can see there's a big shadow right here, so I can't get the camera very close to anything. I have to keep a fair distance away, like right now it's about 6 or 7 inches. So I can't get in nice and tight like I could before with that halo light. I'll have to buy another one because this one is obviously malfunctioning. So anyway, yeah, let's look at this LCD and talk about a few details. So right here you can see the kind of the enable button that you can use for turning things on and off. I don't remember if you can reprogram that as something else. I wouldn't be surprised because, well, Nucular puts a lot of functionality in these things. But me personally, I use that as enable to turn on and off the controller. Right next to it right here, you have a little DC to DC converter. And so here's the control chip for it. There's the inductor up here. So right there, you have 12 volts coming in from the controller that gets applied to this little DC to DC converter, and then it outputs 5 volts. And it's only, I think it's 1 amp. Yeah, I'm pretty sure that's what it was. I did look up this little chip right here to see what its capability was, and I'm pretty sure it's 1 amp. Anyway, so that's your little DC to DC converter. And then right here, this little guy, that's a little 3.3 volt linear regulator. It'd be cool if this had been another DC to DC, but you know, it's doing one job, and that is to provide power to a full-fledged, you know, exact same CPU that you'd find in a VEST controller, STM32. What is that? It's an STM32 F405, if I remember right. Hold on a second, I'll just double check. Get out my magnifier here, look at it, and see if I get, yeah, so that is an STM32 F405. This LCD, and this is pretty typical for Nucular, they don't scrimp, they don't cut corners. This is the same CPU that pretty much all your VEST controllers use. It can handle the full functionality of FOC control like VEST implements it in this little chip, and this one is running the LCD. It does do a lot of things, you know, so like up here you've got all these analog inputs and control signals and things like that. It's doing all of that. It's running the LCD, you know, it's running the SD card slot, you know, it's running CAN bus. You know, it's got all the firmware in the thing for programming the controller. It's got the whole entire user interface that's your dashboard. So, you know, it's a busy little guy, but it's also got enough brain pan in there to handle a lot of functionality that it may or may not be doing right now. So it's pretty darn future-proof for whatever Nucular wants to do with this thing long run. So yeah, that's a nice little feature right there, is, you know, a nice little beefy CPU that can do a hell of a lot. That's not a bad problem to have. That means that Nucular is not going to be limited here. If there are a couple things I would like to see different, and probably the biggest one is the LCD. So it's black and white and it's kind of low res. Yeah, double the pixel count in there and make it color. You know, it'd make it a lot prettier. You know, things would pop out better, stuff like that. Higher resolution would make the screen more readable. Those would all be good. And then the second thing after the LCD is you've got this nice beefy little processor, and there's got lots of processing capability, and yet there's no Bluetooth on here. Why not? You know, that would let you connect all of this to your phone, to an Android or iOS app, you know, for monitoring, or, you know, configure from your phone. I don't know, everything you could possibly do here. Use your phone as a dashboard. Yeah, there's 101 things that you could do with Bluetooth connectivity on here And, well, it's not here, and it's never has been, and I'm pretty sure that when I made that suggestion, they just ignored me, because that's pretty typical for Nucular. They're a bit condescending. If they don't like your idea, they just blow you off. If they don't like your problem that they know about, they blow you off. Yeah, Nucular customer support is meh. Not very good. All right, so let's talk about the controller. That's pretty much everything there that we care about. So, again, let's talk about the bottom side, because that's a little simpler first. Okay, so right there, you are looking at the BAT- bus. You've got 4 shunts on here, and as you can see, they are really surrounded by lots of reinforcing. This is many vias under here. There is copper inside the board, plus all of this on here, which they reinforced with solder too. So yeah, this is pretty beefy. It's not going to be a problem. And from this area right here, inside the board, very much like the same sorts of things that like ASI does. There is copper planes that go up to these. Oops, I'm sorry, I'm off screen. Shift you down a little bit. There we go. So, try to get that oriented like that, and not in the dark. Yeah, had to get another halo light for my camera. So you can see all these spots right here. So you can see all the little tiny holes in it, all those little vias. So I don't know what this is. I'll just have to guess and pretend. So if this little section is battery plus, this one over here is battery minus. And you can see those little vias in there. And then they go through internal, pretty beefy sections of copper to either right there, which is battery minus, this section, or they go over to here, which again, you can see a little vias around it. And they're all inside here as well, to another copper plane that goes to battery plus. And then from there, like you see here, you can see they've got this nice little bit of solder work right up to this pad with all the vias in it. So good current path right up to the MOSFET leg. And like in this piece of copper which is added on, this is the sort of attention of detail you want to see everything to have. And when you don't see it, it's kind of disappointing, because this is very good. You can see that there's this little nubbin of copper right there. Comes right out to the MOSFET leg. There is, close attention to detail. Here's the next one over. Same thing. Comes right up to the MOSFET leg. They literally put a little nubbin of extra copper right there so that there would be direct copper to leg contact. And then soldered between them, of course. But yeah, this is the kind of stuff you want to see. This is a good attention to detail. Nothing here is bad. And you can see, so if this is battery plus and it's battery minus, you notice that every 2 MOSFETs, they have a ceramic cap. Let's move to the next one. Yeah, I'm sorry about that. So again, ceramic cap next to ceramic cap. Yeah, there's 1, 2, 3, 4, 5, 6 ceramic caps on either side of this controller. I.e. 24 MOSFETs, every other one has got a ceramic cap in it. That's very good high frequency ripple filtering, rejection control right there. Nothing there is problematic. That's very, very good. Let's look at this copper some more. Yeah, look at all this stuff. This is absolutely brilliant. Yeah, this attention to detail, this nice thick 2.5 millimeter thick piece of custom cut copper specifically for this, where it literally matches right up to the MOSFET legs. This is excellent. This is very good. Yeah, you want to see this. This is not a problem ever. This is very, very good. Let's move down to this last one here. So this section here, this is that third phase. It's halfway on one side, halfway on the other. And again, custom copper goes right up to the MOSFET leg, and then the leg is soldered to the copper. This is excellent attention to detail. And then just in case, maybe we skimped or missed a little bit, let's put a bridge right across the middle of all that thing on that phase. And then, here is the actual phase wire that joins the 2 pieces of copper together. Excellent attention to detail, good solder flow amongst everything, no little gaps, no little corner-to-corner kind of stuff. And these MOSFETs the same way. Copper's got a little, the main copper reinforcement, got a little nubbin sticking out of it, going right up to the MOSFET leg, and then the MOSFET legs are soldered to them. Good attention to detail. This is excellent. I wish I'd see this kind of thing on everything. Yeah, very happy with that. All right, let's flip the controller over. Again, I apologize for the darkness. Lost my stupid halo light just now. All right, so yeah, you can see the MOSFETs. So each one of these MOSFETs is screwed down with a stainless steel screw that has a lock washer, a flat washer, a plastic washer for electrical insulation, the MOSFET, and then a ceramic backing insulator that's got thermal paste on both sides of it, then the heat spreader. Again, every single one of them, all exactly the same, very good attention to detail. Nothing wrong with that in any way. And all the MOSFETs in here, I don't remember what they are right now, but I've looked them up once before. They're a large name brand Western MOSFET. All the capacitors, you can see right there, Rubicon. They didn't scrimp on anything. This is nice, high-quality components in here. Everything in here is very good. They didn't cut corners. This is on the scale of ASI, just a different format. In some ways better, because, you know, hey, you don't need to do any of the dipshittery that ASI makes you do. You know, there's nobody trying to control how you configure your controller and claiming that, oh, you might blow something up or hurt your children or something. No, you know, they just give you all the instructions how to set up. And by the way, these are very easy to set up. It's not rocket science. It's not super hard. This is not magic. Yes, it's FOC motor control, but it's just not that hard. And, you know, like the guys at ASI, yeah, they are a bunch of control freaks. And, well, Nucular's not. I mean, they are arrogant, they're assholes. You know, they can be seriously condescending, and customer service is kind of sucky at best. But yeah, they're definitely not control freaks. They don't have to manage and micromanage everything you do. So you probably can't see it in here too well. Let me see if I can get a flashlight. That'll help some. But yeah, there we go. So yeah, you can see it down there. There is, yeah, right behind that capacitor, kind of a diamond-shaped thing. That is your MCU right there. And again, that's an STM32, the same one that's on the LCD. And yeah, completely capable little chip, capable of all the full functionality that field-oriented control can offer. No corners cut on that. You can't see it so well. Yeah, you can see that little inductor right down in there. So this board, it has a little DC to DC on it for 5 volts and 3.3 volts. It needs 5 volts for some of the electronics, and like the STM32 needs 3.3 volts, and there's probably something else here that does too. But yeah, it's got a little mini DC to DC on this little daughter board to power its own stuff. Yeah, that's not a bad thing. You can't see it. Anyway, there we go. So you can see these connectors, but underneath there, that's where the MOSFET drivers are. And yeah, they're completely buried because everything in here is very compact, highly integrated. That's not a bad thing. Let's roll this thing around the other way. There we go. Yeah, so this little daughter board right here, this is the DC to DC converter. And yeah, you can see it. So that little thingy down there, that's your inductor. It doesn't show up so well right there, but you can kind of see it where my pointer is. That is a decent sized MOSFET. And I don't remember, I think it's 3 amps. It doesn't really need to be all that powerful. But this little DC to DC, it just outputs 12 volts and takes battery voltage in. And so yeah, that's what powers everything in the controller and the LCD. Yeah, just a little 12 volt DC to DC converter that, you know, is probably good up to, I don't know, 100 volts or so, like everything else in here. But yeah, just nice little compact, custom built DC to DC for these controllers. There's not much else to see in here because it's really hard to see it anyway. You know, there's a few more capacitors down there on the board, a few other small components, but almost everything is on those 2 daughter boards, which are pretty hard to see. Anyway, I hope that helps some folks out, satisfied your curiosity. You know, you got to see the insides of a Nucular controller. They're nicely built, good attention to detail, quality components throughout, Rubicon capacitors, name brand MOSFETs. Yeah, this is there's nothing bad here. Oh, and they even solder the MOSFETs down to the thick part of the leg to the board, unlike ASI. So that's also very good. Good attention to detail, guys. Good job, Nucular.